basically what we're going to cover today is we will be talking about the analyzers, since it is very important. So let's quickly jump on to the analyzers part of it. So an analyzer is the initial step in our indexing or the search process flow. So yesterday we had seen the system flow, right? Once we acquire the document, once we acquire the content, we build the document. What was the next step, which is the first step in the analyzer? Venkatesh, you have any idea? So the first step in the analyzer is the tokenization process. Once the analyzer picks it up, so it has to do some tokenization. Tokenization is nothing but splitting the stream of tokens or stream of words into words or tokens. Okay, so that is the process called as tokenization. So most of the time the tokenization accepts a string reader, which you can pass it to the tokenizer, and the tokenizer takes it from there and splits the words or the tokens and gives all the token stream. So now it is the token stream would be the output. So the tokenizer always takes a reader and emits a token stream as the output, so that the next series of filters based on what you have chosen, it will pick up and it will do some sort of filtering. Say for example, if we have chosen lowercase filter, so each token would be converted into lowercase filter. And just in case, if we have along with lowercase filter, if we have used any synonym filter, so it will expand the each token if we have any synonyms to multiple tokens. So those kind of filters we can use it in conjunction with the tokenizer. So there can be more than one filter. Okay, and eventually the output of the token will be given to the index writer, which will take care of writing all the tokens into the index. Fine. And we also said it will be for different languages. It's not that Lucene can only handle for English or any particular language, so it can handle all the internationalized languages or localized content as well. Okay, so fine. So we have seen some analyzers and some filters, so I'll not dig into this slide a lot. Rather, we will jump into the actual analyzers itself. So let's start with a very simple analyzer. So yes, Venkatesh, so for whenever we wanted to expand our token stream using synonyms, so we will cover in that slide. Say for example, I have a synonym for a word XYZ. So my token string will be expanded based on the mapping what I give it to the filter. Okay, we will see that example very soon. Fine, so let's start with the simple analyzer. So the simple analyzer, what it does is it picks token stream of text and it splits all the tokens based on space by default and only emits the characters data stream. So by default it ignores all numeric data or numeric characters and also non-characters or special characters. So in nutshell, it is a very simple one. It just uses one tokenizer, which is a letter tokenizer with lowercase filter. That's it. So even if you have any year or any numeric text, all of them will be ignored. So if you have any use case where you only have to retain the character stream and ignore all the numeric data or numeric stream in your index or in your documents, so the simple analyzer is the best choice for to use in those use cases. Okay, so you might have noticed yesterday, so the very bare minimum way of instantiating any analyzer is the ones which are provided by Lucene core, and the analyzer component is SimpleAnalyzer. Just say new instance SimpleAnalyzer. So the analyzer component or the interface or the abstract class remains same for everything, and you can just instantiate the SimpleAnalyzer. Rest everything remains same as is what we have seen from the yesterday's class. Okay, is that clear? Venkesh, when do we have to use SimpleAnalyzer? Yeah. So the next one, what we are actually, that one is not required. So the previous versions of Lucene APIs required to mention the version. So now you can remove the version as well. So I'll just show you. So this is not mandatory. You can just ignore. It will pick up the latest version. Okay. What's wrong? Fine. So the next analyzer we are looking into is the standard analyzer. So this one is just an extension of the SimpleAnalyzer, but it has a little bit more features attached to it. So in the earlier example, we have seen the SimpleAnalyzer ignoring some of the numeric characters and all of that stuff, right? So the standard analyzer, it does little bit different from the SimpleAnalyzer. First, it also uses lowercase filter and also uses a stop filter. Say for example, by default it has some stop words like all the common words in, a, the, and. So all those common words will be filtered. So in the SimpleAnalyzer, the stop filter was not used. So in the standard analyzer, there will be a stop filter along with the lowercase filter. Okay. So here in the standard analyzer, even the numeric characters will be emitted from the tokenizer. Okay, that's the differences, few differences from standard to SimpleAnalyzer. Okay. Fine. So this is again a variation of the standard analyzer. Say for example, yesterday we spoke about in some places you may have a little bit more control on the words. The standard analyzer restricts all the standard stop words, but it may not allow you to override any your own bad words or anything of that sort. So in those cases, say if you wanted to restrict a few words getting into your index database, you can create a list of bad words or list of stop words along with the standard analyzer or the standard stop words. You can create a file or you can create a list of words, and using the stop analyzer you can stop all those words getting into the index. So that is the primary usage of the stop analyzer. Okay. So we'll be seeing all of these labs and the variations of it, so that we can, yeah, all the bad words can be given in a string with spaces. Actually, it is not recommended to use that in a string. Rather, we should be using it from a file, so that we can manage all of them in a file by line separated thing. So for the example, I just gave it like that, bad words. That's it. Ideally, a file should be a preferred model. Okay, so this is very interesting one. So at times, say for example, you may wanted to search some words based on the root understanding of that particular word. Say for example, let's take a swimmers example. Say your document may contain swimming or swimmers. Say what if someone is searching with swim and you still wanted to match those documents and return it back. Okay, so in those cases you may have to use something called stemming. Similarly, for the word like if your document has cat like or catty or fishing, fished or fisher. So if someone is searching for say fish or fisher or fished or fishing, irrespective of which word they are searching, they have to match this particular document. So if your application or use case has this kind of requirement, so in those cases you have to use a stemming analyzer. So in the stemming analyzer also it expands the token vector stream so that you can search with multiple terms even though that particular document. So if I use standard analyzer and search for sim, I will not get results. Yes, of course you will not get, and we'll test all these things. Only if you use the stemming analyzer, if you use fishing, fished, fisher or fish, you will be able to get those results back. Okay. So basically the process is defined as to getting the base word of whatever we are trying to get search from the index. Okay, so we will see at least a couple of these examples for this so that it gets pretty easier. Okay, so ideally when we create the analyzer, so there is algorithm by Mr. Porter, so that's the reason it's been named on his name, Porter stem filter. So there is a very exhaustive list of words what the Porter stem filter covers. So if you pass a string, the Porter stem filter will give you the base word for that particular string. Okay, so using the Porter stem filter, we'll be trying out this example. Okay, so there could be another requirement, or in some cases, say for example, you may wanted to add synonyms for a list of words. Okay, say if someone has to search for a word, say completed, over, ended, or finished alternatively. So even though your documents may not contain all these index terms, if you expand by providing the synonym list, so you can search with any of these words so that your users are not blocked with only the term which the documents are containing or only the index what you are looking for, right? So it is a very simple example, right? Someone can type in mobile phone, someone can type in cell phone. So if your documents only has mobile phone, if someone is typing cell phone, you should not stop bringing back those records, right, Venkatesh? So those are the kind of use cases we may have to go ahead and use synonyms so that we can go ahead and allow the users to do whatever they are looking for. Okay, so a very simple code snippet. So I have just taken the same example what we have provided here. So I have added 3 synonyms for finished. So for one I have added completed, over, or ended. So the user can now search with either finished, completed, or over, or ended. Similarly, I have added 3 more synonyms for work as well. So job, labor, or effort. So it might be very tempting to get confused with the base stemmer or the stemming thing, but this is completely different. A synonym and a stemming is different because a stem derives the base word. So this is a synonym or an alternate word which you are adding it for searching for the users. Okay, is it clear? Fine. So I think let's quickly jump on to the lab sessions. So let's start with one of them. So all the lab documents, I'll be attaching it in the zip file format so that you can just extract all the content. Yes, all the synonyms should be given by us either in a file or in the code. So I have used it in the code just to keep it a bit simpler. So you can provide it in the file, all the synonyms. There are multiple ways of creating the synonyms. So we'll see how to handle synonyms as well. Okay. So I'm starting the first lab. So let me just go to the document. I'll be just testing all the lab instructions as well, so that in case if there are any mistakes, we should be able to correct that over the course of trying it out. Okay. So I could see, maybe we can start off with the standard analyzer as per the document. Okay. So let's try the standard analyzer. So I'll explain the code as well. So here I'm using the jar file, which I'll be providing you all the source code. So if you notice, this is the project which I have done it in my NetBeans. So since this is a Maven project, so you guys should not be worried about whether it is a NetBeans or Eclipse. So it would run on any, even on the command line as well. So when I export this, you would get something like a jar file like this. So you can use the jar files to try the exercises, and feel free to go ahead and modify any APIs or anything which is required to be tested, and again redo the exercises on top of your changes. Okay. So the first thing is I'm mentioning the class path of the jar files. Since I'm running from the local folder, I can provide the relative path of my jar files. So the first thing, this is the jar file which I have developed. Followed that, yeah, I have not used NetBeans console, because NetBeans console, again, you'll have a lot of path issues and all that dependency issues. So I have eliminated the NetBeans or Eclipse equation just to make sure people can execute all the lab exercises from the shell or the command line. That way we are not tied up with a path or ID kind of a thing. Nothing stops us from even entering or running it from the Eclipse or NetBeans as well. Okay, because see, the moment we use NetBeans or Eclipse, there will be a lot of path issues, where the NetBeans has been installed, how the folder structures are done. So Eclipse may have bit different folder structure, NetBeans may have bit different folder structure, Windows might have something different, Linux might be something different. So if we follow this approach, everything should run on any platform or on any environment if we have Java. So that was the idea behind it. Make sense, Venkatesh? Fine. So we are providing our jar file followed by the lib folder, where we have added our basic libraries, what is required, or the jar files. Okay. So the documents is the input files. Okay. So this would be your input folder. We have some basic data. I don't have a lot of data right now, so it is just only 2 files. We can just look into it. So this is the index file, so maybe I can delete this just to make sure it recreates again. So I'm deleting the index file, and if you notice, I'm calling my class, the first one index, and the path where I have to index, and where is the input folder. So let's go ahead and see it has created my index. Let's check that one. Yes, it has created. So now since I am testing the standard analyzer, let's go ahead and search the files. Okay, so let me search for Edureka. Okay, so I found it in 2 files, so that's the reason I am showing the file path as well. Okay, so let me check whether it is true or not. In fact, yes, Edureka is in both the files. Okay, what do you expect would happen, Venkatesh? Any guesses? What would happen? It won't return. Okay, I'll tell you the reason why it won't return. So it depends on the query what we are using to search. Okay, I'll come to that topic very soon. Okay, so for now let's understand the analyzers. We'll get into the querying aspect into detail. Fine. So let's see if we have any more examples which we wanted to just quickly validate. Yes, numeric. Let's see numerics. So the standard analyzer has given us the numeric outputs, right? So I think we can try this standard analyzer with different outputs of special characters or anything, and I wanted you guys to come up with problems, and so that we can all go ahead and see if there are anything which we need to explore further. Okay, so let's go ahead and try this one more time. Okay, this time let's try this with the SimpleAnalyzer. So again it has created. So let me just go ahead and do a search. Okay, so let me try the Edureka again back. So great, it is the same results, but let me try 2013 on the same documents. So straight away it didn't return me any document, because SimpleAnalyzer does not get me any numerics or anything of that sort. So that was the reason it straight away omitted my results. So let's just quickly see if I have another test case. Okay, let me just check it out. Let's do one more small example on this, and then we can compare the code differences as well. Okay, so let's add one more small file, file 3, and okay, Even if you have any numerics, the SimpleAnalyzer, it is not accepting it. Okay, so that was the demo kind of thing. So let me just quickly go ahead and show the actual code differences as well. So there is, as I said, there is not lot of differences except for only one difference. Everything remains the same. It was only just one small difference. Here, instead of using standard analyzer, I'm using SimpleAnalyzer. So in the latest ones, you can either remove this entire thing, it is also valid, or you can also say latest. Okay, so ideally it is now not required to provide the version, so Lucene internally figures that out. Okay, so let's see what is the difference from the standard analyzer. As I said, it is everything same except for the where did it go? Oh, here I can show it here itself. So except for this one, everything is more or less same. Okay, so and also you might have been very curious to see what was this entire thing all about, why I was not able to get the partially required token. Where is it? API, come on. So that behavior is because of this query parser and the query, which I'll be just taking it through very soon. Okay, so for now we have seen the standard and the SimpleAnalyzer, just a very basic difference. The only line of change of the change in the lines of the code will be just the construction part of it. Otherwise everything remains more or less the same. Okay, so let's pick up the next one, next analyzers. Okay, so we wanted to also do some StopAnalyzer, right? So I think there is a small, okay, so let's go and try this. Or maybe this was right. Okay, so let's first go ahead and recreate the index. Let me see if I'm deleting it every time so that I don't have to go ahead and do that over and over again. Okay, maybe not. So let me just, yeah, I'm here. Let me just run the index Yes, it has created. And now let me just go ahead and do some search using the same SimpleAnalyzer just to understand the difference. So here, okay, I'm searching something like idiot. Let's see it returns or not. Okay, yes, it did, because I'm using a very simple analyzer. It cannot understand whether idiot is a stop word or not. Even if you use a standard analyzer, it will give you back that document. Okay, so let's assume I don't want these kind of things coming in. So I wanted to go ahead and stop all these things getting into my index. So let me just go ahead and delete it for one more time. And again, I will just go ahead and run. This time I am running the M2 lab2 index files, which is having a different analyzer. Okay, so M2 lab2 index files, if you notice, everything remains more or less as usual, same, except that I have a different analyzer. If you notice, that should be the only change. Rest all should remain more or less same. And if you see, I'm using a StopAnalyzer and I'm providing all the stop words from a file. Let's see what my stop words is all about. So I said idiot, something like a bad word, and rascal as my bad words. So these words should not go into my index. And maybe I have some bad words in my file. Okay, see, training courses Y2K, bad word is the am I rascal. Okay, so these are my bad words, so I don't want some of these things getting into my index. So let me just go ahead and see if it really went in. I could still search on those or not. So now I'm not finding all of these things. So in case of you wanted to override or add your own bad words list so that you should control your index, you can create an analyzer with the stop words and you can do whatever you wanted with that stop words. Okay, so that was the stop words. So let's see what is the next analyzer. I thought we had synonyms, right? Yeah, it was synonyms. Okay, it was yeah, stemming, no worries, anything is fine, the order doesn't matter. So if you notice, everything will remain again more or less same. Okay, so except that I have created my own stemming analyzer and I am passing my class file to the analyzer. That's the only difference. Otherwise, more or less everything is same. Here, see, instead of passing any simple or standard analyzer, I am passing my own stemming analyzer. So this, sorry guys, so this particular lab has got multiple advantages. First thing is we are showing how to do the stemming, and the second one is we are also demonstrating how to write our own custom analyzer. Okay, so yesterday I think you had a question, how do I use all the analyzers together? At one given point of time I said you can use only one analyzer, but you can create your own custom analyzer and add all the filters which various other analyzers composes of, right? So using this, using this kind of a method, you can go ahead and create your own analyzer. Okay, this is the core structure of it. So it should extend analyzer always. Okay, so once you extend analyzer, it asks you to override one method. That's it. Okay, this is the method you have to override. So it returns a analyzer token stream component, and you should say override the create components method. Okay, so once you define this method and override this one, you can create any number of filters starting with the first tokenizer. So I said always in an analyzer the first component is a tokenizer which takes the token stream in the reader format, and then thereafter you can have any number of filters. Okay, so I'm using only one filter here, but if required you can use any other filter as well, Porter stem filter. So here, as I mentioned, for stemming we are using the Porter stemming algorithm to derive the base words. Okay, so now let's go ahead and try some of these examples. I think this one is over, I believe. Let's open the next lab. Okay, so yes, so the reader object is nothing but the data which you are trying to pass it to the tokenizer. That's it. It could be a string reader, it could be a file object content passed as a reader. So there are multiple ways of passing that reader object. For now, for us, this is very simple. It's just the stream of text what needs to be indexed. That's all. Okay. So let me just go ahead and create a new document. Okay, I hope it's already created. Yes. This is for what? Okay. So here the idea behind creating a document with so many words is, say for example, I have either fishing or fished or fisher. So irrespective of whether what word it is, I should be able to search with fish. Okay. Similarly, swimming, swimmers, stemmer, stemming, stemmed. So that is the same file which I have created here. And my objective is, irrespective of what words I have it in my file, I should be able to search with fish, swim and stem. That is the base words for these three records, so that I should be able to search using that. Okay, so let's go to lab 3. Let me just make sure I have deleted everything. Yeah. Okay. So I'm just going and indexing the documents now. So the documents are indexed. Now let's go ahead and do a basic search. Okay. So there we go. So let me just try finished first. Okay, was it finished there? Oh, sorry, fishing. Okay, fishing. Yes, I found. Okay, what was the other one? Fishing, fished. So I found with fishing, I found with fished, I should be able to find with fishes. Okay, so let me try if does it return me with fish as well. Yes, it did. If we have used any other analyzer like standard or simple, we would have not got a match for it. Okay, since we were using the porter stem algorithm, we were able to search with the base word as well. Let's try one more example. Let's try swimming. Yes, swimmers. And I should be also able to, oh sorry, swim. Yes, it returned the document which says it is in the file 3. Okay, so this is the basic use case when if you have a use case where you may wanted to search documents based on the base words, so you may have to use a porter stem filter. Okay, so for this part, so the last exercise would be the synonyms, which we'll just see over here. So again, this is a custom analyzer, so you can create your own custom analyzer by providing the similar syntax and overriding it. So here, if you notice, I am just doing the more or less same thing. In this case, I'm using more than one filter. So I'm using a classic tokenizer. So always the first one has to be a tokenizer. After that, in this case, I'm using 3 filters. Okay, first one is the standard filter, then lowercase filter, and the synonym filter. Okay, the standard filter filters out all the basic standard words which is not required in the default language which we have chosen. Okay, and then the lowercase filter is to convert it to lowercase, and this one is to expand the synonyms for every for every word which we have added it over here. So I have added 2 synonyms and 3 alternate for each synonym. Okay, so let's just go ahead and try this out as well. Okay, so let's go ahead and check the documents what I have got. So I have created one more new document, finished and work. Okay, so what should be my objective? So if you would have noticed, I should be able to search with any of these alternates. So let me just first go ahead and try indexing the documents. Then let me just go ahead and do a search. Okay, so let me just first try something, say finished. Yes, of course I found. So also I wanted to search the same document with the completed synonym as well. Yes, I found what was the one? Over, ended. Okay. Yes, I found ended. Similarly, I should be able to search for work. I should be able to get job. I should be able to get labor. I should be able to get, oh sorry, I was supposed to enter something else. Okay, labor, yes, effort, yes. Okay, so without those synonyms being added into my expansion list, I would have not been able to get all the alternate ways of querying the data. Okay, so this is the basic analyzers which you would come across at least in most of the cases. So we have covered at least some of the basics, and I would say a lot of basics on the analyzers. So is it clear, Venkatesh, on the analyzers? Okay, fine. So I think let's move on to the next topic. Okay, so the next topic we are going to cover is completely on the querying. Yeah, go ahead, Venkatesh. Venkatesh, you said you have some question. Go ahead.